In this video tutorial, we are going to visualize a neural network as a flow diagram. We use the ONNX AI standard, and we will load the model from an ONNX file. We also use the ONNX Sharp NuGet package, which provides a .NET API for parsing and handling files in the ONNX formats. For visualization of the graph, we use the MindFusion Diagramming library for WinForms, but you can use a diagramming library for any other platform. Code will be similar. We create now an empty WinForms project, which we name Neural Network. Let's open the NuGet Manager and search for the packages we need. First, ONNX Sharp. Here it is. Let's add it. Then we look for the WinForms diagram library. It has to be this, the flowchart.net control. We add it as well. The packages are installed. So far, so good. Now let's get to the form that represents our application. We will add to it the diagram. First, we need to add a diagram view. We need a standard diagram view, which we make stretch on the form. Then we need to add the diagram, which has to be bound to the diagram view. A useful control will be the overview control. The diagram is going to be large. The overview is ideal for fast navigation on large graphs. And last but not least, it helps us see the whole diagram, albeit in a tiny size. Now, if we run the sample, we should be able to have the ability to create some basic flow diagrams and preview them. Yes, that's right. Let's make the overview window larger, so we can actually see better the big diagram. Here it is. When we draw new nodes, they appear on the overview, and we can quickly navigate through the whole diagram. So far, that's been only the setup. Let's start the real coding. First, we need to add the diagramming namespaces and the ONNX namespace. Let's first set the fitAll property of the overview control to true. Then, I will copy in an ONNX model file to the main directory of our project. The file is taken from the Models section of the GitHub ONNX project. A link is provided in the video description. Next, we will handle the load event of the form. We get the model, created after our ONNX file has been parsed by a model proto instance. The model proto class is, quote, a top-level file / container format for bundling a machine learning model and associating its computation graph with metadata. End of quote. So, the model variable now contains tons of useful data, parsed and organized from our input file. Next, we get the graph of the model. This is the graph that is used to evaluate this model. We will get its nodes and map them to diagram nodes. For that, we initialize a dictionary. The key will be a node proto-object, which represents a node in the model graph, and the value will be their respective node from the MindFusion diagram. Now we are going to iterate through all nodes in the graph and create a table node for each of them. We use the createTableNode method of the factory class of the diagram. This is a static method. The location of the node is of no importance because we will use an automatic layout to arrange the graph. Our table node initially has 2 columns and 1 row. Let's add some styling to it. The cell frame style is simple. And we can use a nice color theme from the Adobe website for the node brushes. The brush will be lime green. No, let's make the caption lime green and the background of the table will be beige. This should look good for the ML graph. The first row of the table node will render information about the operator that was executed at this stage in the graph. Some graph nodes might have attributes, so we are going to cycle through them, if any, and add them to our table nodes. We add a new row with the addRow method and get the index of the newly added row. Then, just like with the first row, we write the name of the attribute in the first cell on this row, the type of attribute in the second cell. We have a few more things to do before the table node is ready. First, we call resize to fit text on the new node with false to make sure the nodes remain the same size and do not stretch or shrink according to the text. We set the caption, and then we specify that the connection style will be table. This means that table nodes will be treated as whole objects. Finally, we set the newly created and styled table node as value for this network entry in our dictionary. We can run the sample now, and if everything is correct, we should be able to see the nodes in the graph represented by table nodes. Before we do it, let's make the ONNX file a content and make sure it gets copied to the output directory. So, here are out nodes. Of course, there are tens of them, even hundreds, but they look very good. Let's connect them now and arrange them properly. What we are going to do now is cycle through all graph nodes, take their outputs, and see there is a node, which has input the same as the output. This would mean that the nodes are connected, and we will create a link between the table nodes that represent those graph nodes in the model. We cycle through each graph node and then through all output nodes of it. For each output node, we need to find if there is a graph node, whose input is the same. If the graph nodes are the same, we omit this node and go to the next one. When we find a pair of nodes that have the same output and input nodes, we create a link. We are going to arrange the graph with the layered layout, which is the right algorithm in this situation. Let's look at in the online documentation. The layered layout class has quite a lot of properties. We will use enforce link flow, which we'll set to true, and ignore node size, which will be false. So let's do it. All layout algorithms are applied with the arrange method, which is called on the diagram instance. We also call resize to fit items, which means the diagram area will be resized to fit all diagram nodes and links. The parameter specifies the size of the margin. And here is our diagram. It looks lovely. The links can take some styling, which we'll do in the final version of the code. And that's all for this video tutorial. Thank you for watching, and thank you for your interest in MindFusion Developer Tools.